We usually think robots are a modern miracle, machines powered by electricity, code, and artificial intelligence. But here's something most people have never been told. Robots existed 800 years ago, not as science fiction, not as imagination. Real machines, real movement, real automated behavior, and they were built in a world with no electricity, no computers, and no modern technology. So this raises a disturbing question. If robots didn't need electricity, if intelligence didn't need software, then what exactly makes a robot a robot? And how did one man solve this mystery centuries before the modern world even existed? Before we go any further, let's clear up the biggest confusion. If there was no electricity, how could robots exist? Electricity is not what makes something a robot, it's just a power source. Long before electricity, humans already knew how to create motion using other forces. Water flow, gravity, weights and pressure. Water mills turned on their own. Mechanical clocks ran for hours without human touch. These machines didn't think, but they worked automatically. And that's the core idea behind robots. Automation, not electricity. If technology wasn't modern, how could robots exist? Here's the mistake many people make. They assume modern technology means intelligent design, and old technology means simple machines. In reality, medieval engineers used incredibly advanced mechanical logic. Gears, valves, levers, cams, all working together to create cause and effect. If the water level rises, something moves. If pressure drops, another action begins. It's the same logic software uses today, just expressed physically instead of digitally. Mechanical if-then rules. So what did robots look like 800 years ago? Not metal humans walking around like science fiction. They were automata, machines designed to perform actions automatically, to repeat tasks, to imitate specific human roles, playing music, serving water, keeping time. They didn't look human, but they behaved with purpose. And one man understood this better than anyone else. Al-Jazari lived in the late 12th and early 13th century. He worked as the chief engineer for the Artukid rulers in what is now modern-day Turkey. This position mattered. It gave him something rare for his time: resources, time, and powerful patrons who supported experimentation. He wasn't just building machines for survival, he was building them to solve problems and to amaze. Around the year 1206, he compiled his knowledge into a remarkable book, the Book of Knowledge of Ingenious Mechanical Devices. It wasn't theory, it was detailed engineering, step-by-step instructions, precise diagrams, real machines that could actually be built. But his ideas went far beyond simple mechanics. One of Al-Jazari's most fascinating creations was a boat carrying mechanical musicians. They played music automatically, without human input. Even more impressive, the rhythm could be changed. By adjusting physical components, the behavior of the musicians changed. This wasn't random motion, it was controlled, repeatable behavior, an early form of programmability, not with code, but with mechanics. Al-Jazari also designed machines that acted like servants, devices that poured water for washing, others that served drinks. Once activated, they completed the task on their own. No human control mid-process, no external adjustment, just a trigger and a response. This is a key concept in robotics, task-based automation, a machine performing a function independently. Then there was the elephant clock. More than a timekeeping device, it was a masterpiece of engineering, moving figures, timed actions, multiple systems working together. water flow controlled timing, motion-triggered visual responses. It also carried cultural symbolism, blending elements from different civilizations. But at its core, it demonstrated something powerful: complex systems, precise timing, and automated movement, all in one machine. And this is where Al-Jazari crossed a line no one else had before. Al-Jazari's machines weren't just automatic. They were adjustable, predictable, and repeatable. By changing pegs, adjusting water flow, modifying weights, the machine's behavior changed. This is critical, because programmability isn't about computers, it's about control over behavior. Al-Jazari didn't invent robots with code, he invented robots with mechanics. And that idea would quietly shape engineering for centuries. Modern robots are digital. They use sensors, programs, and electronic actuators. Al-Jazari's machines used mechanical equivalents. Water levels acted like sensors. Mechanical settings worked like programs. Moving parts served as actuators. Different tools, same principles. That's why many historians see Al-Jazari as a conceptual ancestor of robotics. Not because his machines looked modern, but because they behaved intelligently for their time. His influence reached far beyond entertainment, into engineering, automation, and systems thinking. Al-Jazari's name isn't as famous as it should be, but his ideas outlived him. Robots didn't suddenly appear in the modern age. They evolved, slowly, mechanically, brilliantly. And long before electricity or artificial intelligence, one engineer proved that machines could act with purpose. If you enjoyed this story, make sure to like the video and subscribe for more documentaries exploring the hidden history of technology. And if you're curious about other minds who were far ahead of their time, I've already covered the story of Nikola Tesla, a genius the world misunderstood. You can watch that video right here.